This video is a Key Stage 3 guide to electrical safety. So what you can see on screen is what's known as a Lichtenberg pattern. This person has been struck by lightning in their arm, and the lightning has spread through their arm much in the same way as it does through the sky. Now what you can't see is the fact that the Lichtenberg pattern in fact spreads into the body, deep under the skin. Now this is caused by the fact that extremely large currents, such as that in lightning, increases the temperature of things, and so this is in fact a burn caused by the lightning. So what we're looking at today is electrical safety. By the end of this, we need to be able to describe some dangerous activities involving improper use of electricity in the home, state the rules for making safe circuits in the science lab, and finally explain why the safety rules are necessary. Now we'll draw out our notes in this fashion. We'll have electrical safety written across the top, and you will have a large margin, about 1/4 of the page, for you to write your learning objectives. You should then write in your notes any answer to those learning objectives on the left. Finally, you'll write a summary at the bottom, and the summary will be where you write what you have learned today in your own words. So, using an appliance with a damaged electrical cord. So if you touch that metal, the electricity can then travel through your body. Putting anything metal into an electrical socket. Metal is a good conductor of electricity, and so if you put anything metal into a socket, the electricity can pass through the metal before it then passes through your body. Touching an electrical device with metal. So yet again, it's the same as the last, only this time some electrical devices have bare wires inside them, such as a toaster. Again, the electricity can pass through the metal and then through your body. Letting an electrical device get wet. So in this case, the electricity can sometimes pass through the water and then pass through your body. Finally, putting too many plugs in one socket. So in this case, again, like with the lightning, a large electrical current increases the temperature of something. So if you put too many plugs drawing electricity out of one socket, the socket will have a large amount of electricity going through it. That will heat it up, and it can get so hot that it will catch fire. So, the dangers in the lab: burns when you touch a hot wire, electrical shocks when you touch a bare wire, that is to say the metal inside the wire, not the plastic on the outside, and finally fire. When the whole circuit gets too hot, it can in fact catch fire. So, rule 1, add a switch to your circuit and turn off the switch when you are not using it. This prevents the circuit from getting too hot. If you leave an electrical circuit on for a long time, it increases in temperature. So we should always turn it off when we're not using it. This also allows us to turn it off so that when we rebuild the circuit, we're not touching it whilst electricity is running through it. Don't let the wires get tangled. Now in this case, if you have tangled wires, it's almost impossible to tell which wire fits into which component, so you might end up miswiring it. Now if you miswire something, you can end up plugging something straight back into the battery through which it came. In this case, we have here an electrical cell in which it is being plugged back into itself. Too much electricity then passes through it because there's nothing to slow the electricity down, like a light bulb or a resistor. And so this causes the wires to heat up. This can then lead to a fire. Don't touch it when it's on. So this is again why we have our switch. Do not touch any part of the electrical circuit while it is still on. You should turn it off first before dismantling it. Report a smell. Burning electrical devices have a very distinctive smell. If you smell anything really out of the ordinary, you should let your teacher know immediately.